Okay, so what if the next voice you hear from an AI wasn't just a voice, but a real personality? What if it could actually convey emotion, nuance, and speak just like a person? Well, it turns out one of the world's leading AI labs, Mistral, just made a huge leap in that exact direction, and they're tackling one of the most personal ways we interact with technology every single day. Let's dive into it. And here it is. This is the big news. Mistral just announced Voxturl TTS, their new, what they're calling frontier open weight model for text-to-speech. And just look at the promises they're making right there. Realistic, emotionally expressive speech. Plus, it supports 9 languages, has super low latency, and it's easily adaptable. Believe me, this is not just another minor update. This is a really fundamental step toward making how we talk to AI feel, well, more human. So let's get right into it. What exactly has Mistral built here? And what makes this new voice so different from everything else out there? All right, at its core, Voxturl is just a powerhouse of efficiency. First off, it's an open weight model, which, by the way, is a huge deal, but we'll circle back to that in a bit. It supports 9 languages right out of the gate, and what's really impressive is its size. It's only a 3 billion parameter model, which means it's compact, and that means it's fast. Like, really fast. Perfect for real-time conversations. And that last point, easily adaptable, that is the secret sauce for making AI voices truly personal. But you're probably wondering, how good is it really? Well, this chart tells a pretty compelling story. In a direct head-to-head matchup against a top-tier proprietary competitor, 11 Labs, Voxturl won over 68% of the time. Now, that is not a small margin. It pretty much proves that Mistral has an open-weight model that can go toe-to-toe and even beat some of the best closed systems on the market. So the big question is, how did they do it, right? How does it actually get past that robotic, kind of flat AI voice we're also used to and create something that sounds, well, human? The answer, it turns out, is in a really, really clever piece of architecture. So let's pop the hood and take a look inside. We're going from what it is to how it works.
Okay, this looks complex, but the idea is actually pretty brilliant. You see how it all starts with that autoregressive backbone? Think of that as the model's central nervous system. But then it splits into 2 separate paths, or heads. One head is focused entirely on the meaning of the words, the semantic stuff. The other head is obsessed with the sound, the acoustic information. This dual-path approach is the key to its success.
And this slide right here really gets to the heart of the challenge. See, predicting the next word in a sentence, that's relatively straightforward for an AI. But predicting how that word should sound, that's a whole different ballgame. I mean, think about it. You can say the word really in a dozen different ways to mean you're excited, sarcastic, or doubtful. The AI isn't just predicting one right answer, it has to pick one natural sound from a huge range of possibilities. So, how do you solve for that massive complexity? Well, Mistral found the answer in a technique that has a pretty fascinating origin story. They call it their flow matching secret. Let me break this down. Basically, flow matching doesn't try to predict the average way to say a word, because think about it, that would just sound muffled and unnatural, kind of blurry. Instead, it models the entire landscape of possible sounds, all the different inflections, all the tones, all the pitches, and then it can intelligently pick one sharp, clear, and natural sounding point from somewhere within that landscape. And here's the lead of the Voxturl project, Pavan Reddy, explaining exactly why this is so important. He says, even the same word could be inflected in so many different ways. Any approach which models this distribution is better. It's all about capturing the incredible richness and variability of human speech, not just some robotic dictionary definition of it. And here's the really cool part. This technique, it wasn't even born in an audio lab. Flow matching is actually a super popular technique in image generation. It's what models like Stable Diffusion use to create those incredibly sharp, detailed images out of what starts as just random noise. So Mistral very cleverly adapted this visual technique to do the same thing for audio, turning abstract text into crisp, clear speech. So we have the tech, we understand how it works, but what's the big picture vision here? I mean, why go to all this trouble? Well, the answer is about fundamentally changing how we talk to our devices. Mistral's chief scientist, Guillaume Lampel, just puts it perfectly. You know how when we talk to our current AI assistants, we change how we speak. We talk a little slower, we over-enunciate every word. As he says, it's not natural, right? That's the gap they're trying to close.
The end goal here is to build what's called a full duplex conversational agent. That's a fancy way of saying an AI that can speak and listen at the same time. One that can interrupt you and that you can interrupt. An AI that can handle the natural, fluid, and honestly sometimes messy flow of a real human conversation. But beyond just having better chats with our gadgets, Voxtral's open-weight nature unlocks a massive opportunity, especially for businesses. And this is where we really get into the why this matters part for anyone building with AI.
For years, if you were a company using a closed proprietary AI model, you probably ran into the same walls. You're worried about privacy, about sending sensitive data to some third party. You're sitting on decades of incredibly valuable, unique data that you can't even use. You end up using the same generic AI as all your competitors, and then when you try to scale it, the costs just become insane.
So check out how Mistral's open-weight approach directly solves every single one of those problems. 1. You can deploy the model yourself, in-house. Your data stays private. 2. You can fine-tune it on your private data, teaching it your specific industry jargon or even the weird acoustics of your call centers. And 3. You can build a truly unique competitive advantage, an AI that knows your business better than any generic model ever could.
And the result of all this is deep, meaningful personalization. We're not just talking about an AI that understands medical terms. We're talking about a bank being able to create a voice that sounds authoritative and reassuring, or a retail brand creating one that's friendly and super upbeat, a voice that perfectly embodies their brand. And Guillaume Lampel really drives this point home. He says using a closed source model is really sad because you are not leveraging all this data and you are going to be using the same model as all your old competitors. It's a powerful point, right? Why use a generic off-the-shelf tool when you have the data to build a specialized one that gives you a real edge? Which brings us to a final thought. We've talked about the tech, we've talked about the vision, and the business case. But the bigger question still remains. As this technology keeps getting better, and that line between a human voice and an artificial one starts to disappear, what does that mean for us? What new relationships, new interfaces, and what new kinds of conversations are we about to start having with the technology that's all around us?